Welcome everybody. This here is the video that supports the Intro to Wave Theory booklet. This booklet right here, it's got two little QR codes that can kind of, help guide where you're at. If what I've got for you isn't good enough, they're little extras. And in this booklet, we explore the idea of what is a sinusoidal graph. Okay, so we're talking about two types of graphs. One with a sine in it, so y is equal to a sine b of x, so a and b or numbers of some sort, and x of course is your variable, so what does the graph look like? And same thing with a cos b of x, because remember cos is cosine, right? So that's why they call them sinusoidal graphs. Just saying. So the big things that we worry about here are something called the amplitude and the period of the graph. So A over here, that represents the amplitude, and B represents how to figure out the period of the graph. And we'll look at both these types of graphs and how to calculate those values. It's a pretty quick lesson today. It's easy, so you got a nice easy one to work through. Alright, so we'll jump in. Okay, so like in the regular class, I would go through the construction of the graph, and we'd have a look at the table of values for the first circle, so for angles between 0 and 360. And really, I want to look at particular angle values and then also reference angle values that are simple and easy to calculate on our calculator. So we're looking at 30, 45, 60, those intervals in between our perpendiculars. So that will be our first quadrant between 0 and 90 if you're thinking about it in your mind's eye. Right, if I think about it up here, 0, 90, right, if I think about that, all my values are positive in that region for sine, because remember sine is also positive here, so S, sine is negative in T, and sine is negative down here for C, right, so our CAS rule. And so we're going to kind of keep that in the back of our mind as we're going through these numbers. But I'll set up the rest of the table of values. So if you're kind of taking notes at home, then you might just want to pause the video here and set up a table of values for yourselves. We're going to fill in these numbers. And what's important here is that there's only really 4 numbers that you have to know. And, okay, 5 if you include 0. But there's only 5 of them, and all of these slots, all these y values on this table of values will be one of those 5 numbers. And so it looks like it's quite a daunting detail, but it's not. It's actually quite simple to do. And I'm not asking you to memorize them or anything like that, but it's a way for us to see how the shape of the graph looks when you sort out the table of values for the first time. So let me go ahead and fill in the values, and then we'll look at what the graph looks like. Alright, so, you could do this by your calculator, and that's fine. The thing to remember over here is that we start off at sine 0 is 0, then I got 0.5, 0.71, 0.87, and then 1. When we get to 90, so up at the top over here, when I get to 90 degrees, my sine of that is equal to 1. And then I keep going back down, and my sine will, you'll see it here, starting to go back down in numbers. So it was working its way up to 1 over here, got up to 1, now it starts working its way back down, goes to 0. Notice that these numbers here are the mirror image of these numbers over here, so there's lots of symmetry involved. That's why you don't have to remember very much to do it well. And that's 180, so at sine 180 I'm left with 0. And then back over here, right, I'm starting at sine 180 again, just to show that these numbers here, right, that 0.5 and that 0.5, well, one's positive and one's negative. So the numbers are the same, it's just that they are different polarities. So same numbers, I'm going down towards -1, I get to -1, and I start climbing back up towards 0. Okay, so that's the table of values, and you could do it for any angle in there if you want, but we don't need to, kill ourselves with extra work on that. So let's have a look and see what the shape looks like. All right, the thing to remember about this graph is that it's very long and thin. It creates a wave, basically. So a wave oscillates backwards and forwards. It doesn't get very high, it doesn't get very low. So it's long and thin. And when you're graphing them out yourselves, and this is what I would typically ask my students to do, is to say, okay, we're going to set this up. Now, when you set it up, you start off with 0 over here for 0 degrees along your x-axis. And we're going all the way to 360. So somewhere near the end, write your 360 in. So, like, you know, we're just doing a rough sketch of this. When you have proper graph paper, you can be finer. Okay, so what's halfway between 0 and 360? Well, that's like 180. So somewhere in the middle here, you can draw yourself a 180. Okay, so, I know it's not quite half, I get it. And then halfway between 0 and 180 is 90, so you can draw another halfway point. 90. What's halfway between 180 and 360? Well, I'm counting it by 90s, right? So 90, so 9, 8, 180, so 18, 9, 18, 27, so 270. Okay, so these represent our distance markers on the graph, and we know that starting at 0, like 0 value, sine is 0. At 90, sine goes all the way up to 1. At 180, sine goes down to 0 again. At 270, I'm down at -1, and 360, I'm back up to 0 again. And then along the way, we have these other markers, right? So at 30, right? So, you know, kind of a third of the way there, I'm at 0.5, so halfway already. 45, next one down, right? 45 is 0.71, just like that. 60, getting closer. So I'm making my way up towards 1. And then I start making my way back down again. Now, in each interval, right, between, you know, 0 and 90, I have 3 indicators, three notches. Between 90 and 180, right? So between 90 and 180, I've got 3 more, right, to plug in, same distance apart. So 1, 2, 3. And we start going back down. So 0.87, 0.71, 0.5, and then back down to 0. Just like that. Now my awesome art. I get it. I can feel you mocking me behind that screen. I know you're there. Okay, and then on the other side, down below, they're doing the exact same thing. We're working towards, you know, so 180 going down towards that, and then back up to 360. Same idea, right? 3 notches. There we were down there. Kind of looks like that. And then 3 more notches, and then back up to 360. Okay, fairly good representation of a sine graph. So when we do the cosine graph, it's the same idea, all right? It just looks a little bit different, and then we'll talk a little bit about you know, amplitude and period and those sorts of things. Okay, so I'll just quickly set up what the cosine graph looks like. Oh, sorry, this one is for cosine. Alright, sorry about that. This one is for cosine, and so that's the black graph. The red one was the one that we did for sine. So sine starts at 0, goes up, comes down, goes all the way down, and then comes back up again. Right, so that's the sine graph. Cosine, if you work out the numbers, starts at 1, goes down to 0, down to -1, back up to 0, and then back up to +1, and it creates that cycle. And so these are the 2 main graphs that you're responsible for knowing. And you know, you'll be doing so much work with these 2 graphs that you'll begin to know the differences pretty easily. So a couple little details of knowledge about this. The height, so the difference between the top and the bottom, which we call the amplitude, is equal to the top minus the bottom. Sorry, is it minus the bottom? Yeah, top minus the bottom divided by 2. So 1 double minus 1, so 2. 2 divided by 2, my amplitude is equal to 1. And if you have your baseline or your starting point as the x-axis, then your amplitude is just the top number on your graph. So your amplitude is the highest part, and in this booklet, that's all we worry about. Later booklets, we worry about shifting them around, and so we're kind of coming back full circle. Ha ha, circle. Full circle. I know it's a bad joke, sorry. So we're coming back full circle to what we did in September, where we're shifting graphs around. And so we're going to be looking at how these graphs shift around, and what does that mean, what does that do. So that's the amplitude, and the period is the distance between the start of one cycle and its finish. So this huge expanse, so we started at 0, and when we got back to 0, that whole distance, so here my period is equal to 360 degrees. And that period will depend on different factors. So the next thing that we're going to look at is what happens with the equations, and how does some simple changes of the equations change the way that the graph is structured. And so hold on tight, here we go. So let's just keep these two kind of shapes in mind as we progress through this. I'll kind of want to leave these up here for us to reference back, and it's probably a good idea for you to copy this out onto your booklet or something like that, so you have quick and easy access to these shapes. So you're going to use them a lot, and it's nice to have them committed to memory because it just makes it faster. But until that happens, it's good to have some sort of reference. And these are the sorts of things you would put on your formula sheet if we were doing proper tests. Alright, so if you have a sinusoidal equation, so it could be sine or cosine in here, it doesn't matter because they both have the same effect. So just use sine, but it works for cos too. So the amplitude is the absolute value of the number out front. It's a horizontal, it's a vertical expansion. That's what an amplitude is, right? I'm expanding it vertically or shrinking it, depending on what I'm doing. And your period, right? The length of the wave, right? Well, that's a horizontal expansion or contraction, so that's like your b value. And so it's your period divided by your b value. Or if you're using radians, it could be 2 pi divided by b. So let's just have a look at some quick examples. Okay, so you'll get questions like these in your booklet, and I'll say, okay, so here's the equation, y is equal to 3 sine 2x. What's your amplitude? Well, your amplitude is the absolute value of that number. So that would be the absolute value of 3, so your amplitude here would be equal to 3. If this was a negative 3, you take the absolute value of negative 3 and it would still become 3. So your amplitude is always positive, right? So I'll just take that out of there because that's not what we started with. The period, right, is 360 divided by b. So this is going to be 360 over 2. So half of 360 is 180. Closer. Okay, easy enough to do, or I could be like, if I was using radians, it would be 2 pi over 2, right? 2 pi over 2, and that would cancel out, so you just have pi. 180 is pi from radians and all that. Okay, so for the other example, maybe I'll just give myself some extra space here. I don't need to constrict myself. The absolute value of that number is your amplitude, so that's the easy one, right? And then your p-value, your period, well, that's going to be 360 divided by a half. So you're like, yeah, that's 180 again. So 2 and a half both give you 180. That's wild. No, that's not wild. It's not how it is, right? 360 divided by a half is 720. What? Yes, because you're dividing by a fraction. Do it on your calculator. 360 divided by 0.5. 720. Because we really have this. 360 divided by, that's what that says, a half. Yeah, a half of 360. It's 180. What's wrong with you, Mr. Gerard? when you divide fractions, 360, you got to change it to a multiply and flip the fraction. Right there. Okay, so just be careful about that, right? It's the kind of like the you're dealing with a reciprocal situation. Maybe you can remember back to September how that plays out. Okay, so let's have a look at a couple of the details. Okay, so I want to kind of improve our literacy with radians a little bit, and so I want to do these next two examples with radians. So we're using your period is 2 pi, right, instead of 360. And there's a couple tricks to be aware of on this, especially you'll see them in the booklet. And if you're not paying too close attention, you probably go on and you'll be making a bunch of mistakes and you won't even know it until you check the key. So let's have a look and see what's going on here. Now if you look at these two questions, the only thing that's different about them is one of them has a pi for the b value, this guy over here. Right, that guy has a pi for the b value, and this guy over here doesn't. So that's the only difference. My a values are the same, so my amplitudes are the same. So they're both going to be positive 5 over 2, whatever that number is, and you leave it as a fraction. Let's talk about the period. That's a little bit more skillful to sort out. All right, so if I'm asking you about, to calculate the period for these guys, because the amplitude is simple. Then this is how you'd be sorting it out. These are your b values, right? There's your b value there, so that's that. And then the other one, there's your b value there, so that's that. And if you're good with fractions, then bada bing, bada boom, you're fine. But if not so much, and if you're like me, sometimes I gotta think twice about that sort of thing, then, just be careful. Because once you get a couple of these under your belt, you'll see the pattern and it'll be fine. But, you have to think about this until you start recognizing how the pattern plays out. So let's just take a look. Okay, so I just, I set it up as a fraction divided, fractions dividing fractions, and go through all those rules for dividing fractions, and flipping the denominator, how you deal with fractions. And I wind up getting 4 pi over 3 units. And that's your period, and it's usually units of time. Not always, it can be other things too. So we'll just call it 4 pi over 3 units. That's your period length. That's the length of the wave of that function, of that graph, the cosine graph. Let's have a look at the other one. Okay, so you guys see what cancels out? Just saying. Yep, the pi does. And so that's an interesting little tell in your equation to know that, when the pi cancels out, you're usually left with things like seconds or minutes and stuff like that. And eventually we'll be constructing our own equations to model events like a position on a circle, like a Ferris wheel, the ideal form of a wave, like say a tidal wave, and how to sort those things out, and how to write them so that the pi's cancel out and you're left with just units like seconds or whatever. So in this case the pi's cancel out and we're just left with, okay, so 4 over 3. And so in your booklet you're doing a matching section where you have to take care about those things. Otherwise they'll you'll be doing them and you'll check and you'll be like, what's going on? This is what's going on. So when we do our modeling of this concept, we'll be looking at situations like this and harder, more difficult. For right now, this is good enough, and this is the kind of detail you'll sort out in your booklet. So I'll ask you to write the equation of a cosine graph where top is equal to 7, bottom is equal to -7, and it has a period of 30 minutes. So I'm just going to sketch this out so you can see kind of what it looks like, and then we'll just fill in the parts of the equation that we need. Alright, so there's kind of what the graph looks like. Remember, it's a cosine graph, so it starts at the top, goes down the bottom, and then comes back up. And this is what we call our first iteration of the wave. Iteration. It's not really a word you use a lot unless you reiterate it. Yeah, I just made another dumb joke. So, to reiterate, right, is to say again, right? So if I'm reiterating this piece of information to you, then I'm saying it again. So it's iteration, it's first iteration, so I'm not reiterating, I'm just doing the first iteration. This is the first kind of copy of the graph. But then, it's a wave, so it keeps going and going and going and going. So those are the, second, third, fourth iterations. So this is the first iteration. Okay, it's a word you'll see me use a little bit. It's not like you have to memorize it for a test or anything like that, but you can think of reiterate to help you sort that out. When I first saw that word out of the context of reiterate, I didn't know what the heck was doing. I was kind of too shy to ask, and then I had to kind of figure it out the hard way. So yeah, this is your first iteration of the graph. Your first period length is 30. Okay, so if I want to write out the equation, I have to come up with an a value. So we're doing cosine here. Don't give me any dings, I'm on to you. Cos b of x. So we have to fill out our values for a and b, right? And you could do it the formula way. So a is equal to the top minus the bottom divided by 2 if you want to do it that way. So 7 minus negative 7 over 2, so 14 over 2, that's equal to 7. When your like I said, when your baseline is the x-axis, then that's just your a value. So a is equal to 7. Okay, your b value is going to be, well, you can use pi, you can use the radian ones, or you could use the degrees. It doesn't matter. So I'm just going to stick with degrees for now because we just did a bunch of radian stuff. So this is 360, your period is equal to 360 over b. So I know the period, right? The period is 30 minutes. So how do I find b? Well, we got to give our proper thanks to Mr. Duick for remembering us about the swappy dance. And you can do the swappy dance here like that, bada bing, bada boom. You can also do proper algebra if you like. And I get b is equal to 360 over 30. So 36 over 3 is 12. So 12. And there's your b value. And then you just fill them in. So I've got 7. And I've got 12. Pow. Now, what do you think would happen if I had this? Still a cosine graph, but now it's reflected in the x-axis. So, and I'm not really entirely clear in my original question about which one it is. I'll just tell you which one is the top and which one is the bottom. Now, in the first one, the black one, I've got the top going first, right? So that's positive cosine. But if I reflect it in the x-axis, then that would mean that that's a negative. And we'll talk about positives and negatives in the next booklet as we go through those sorts of details. It's just a little bit of foreshadowing for you. So this really takes us to the end of that booklet. I know I'm talking, sorry. At the very end, you got to do some very simple graphs that get you to set up the table of values. But the key is there, so you can kind of use that to guide your learning. And don't forget, you'll always have the opportunity to speak with me on Fridays at 1:30 for my office hours. Just look for the little link in the Edmodo. Okay, so take care. Stay safe. We're starting to come out of the woods now a little bit. Ciao.